All right, enough with the funny business. In this video, we're going to look at possible triangles that happen in the SSA case, meaning I know a side, and an angle that's not included in between the two sides. Now, you can use the law of sines to solve such a triangle, but there are some weird things that go on here. Okay, so let me show you a couple of examples. First of all, if we have the SSA case, side-side angle, it's possible that we know that the angle that we're given is obtuse. Okay, and I've got two different angles for you here. If my angle is obtuse, and I know two sides, including one of them that's opposite this angle, I've got a couple of options that could happen. It is possible that that side length is less than, so I'm going to use the compass to draw them on here. So we're going to say that the side opposite A is less than side B. Now I want you to see what happens. If my side is only this long, from here to here, no matter where I would put it, that's all the further that that side could reach. Okay, so if you can imagine that hanging out there, I'll move this. That side length, side A, only goes as far as that red arc would let it. So no matter what, is it going to reach the other side of the triangle? No, there's no way for it to get there because it's not bigger than the side that's next to the known angle. Okay, so if this is the case, if I have an obtuse angle and the side that is opposite the given angle, in this case we'd call that A, if that guy is less than or even equal to, because if it's equal to, it still won't, it'd get all the way there, but it wouldn't make a triangle because it's not going to reach all the way to the third side. If A is less than or equal to B, if the side opposite the angle that we know is less than or equal to the adjacent side, there is no way that that makes a triangle. And we would say so. No triangle, or zero triangles, however you want to put it. It's impossible for those measurements to make a triangle. Okay. Now the other option would be for that side length to be, put it down here, and we'll spin it a little bit. If this is bigger than side B, well, in that case, no matter where I put it, no matter what that angle is, if it's bigger than side B, it's going to go from here to wherever the red arc is, and boop, it would make a triangle right there. In that one spot, because it's definitely longer than B, it's going to reach that far, and it makes a nice triangle for us. So the thing we would write down here is that if A is greater than B, if the opposite side is greater than the adjacent side, in this case with an obtuse triangle, we have one triangle. Okay? So obtuse, there are two options. We either have a triangle or we don't. With acute, got a couple of different things going on here. So use the compass once again. We've got the included for all four of these options. We've got angle A is the one that's given to us. We know side B, the side that's adjacent to it, and we know side A that's opposite. I've been drawing it in because I'm going to do that with the compass. Okay. So my first option is perhaps the side that's opposite the known angle. What if it were, I don't know, shorter than the given adjacent side? Let's say it's about this long. Okay, it's shorter than B. Now, if it's about that long and I draw this arc, if that's all the longer that that side is there any way for it to reach this side and make a triangle? No. So let's say it extends to here. Oh, it's too short. No matter where it is, it's going to be too short. Okay. So now, how do we determine whether or not it reaches there? We'll get to that in just a second. So just know that the answer to this particular scenario is zero triangles. Okay. We'll explain the why in just a second. Now, another option is perhaps my line. Try to draw this here. Maybe I'll just draw a line. What if this line were to go straight down like that? If that's the length of the side opposite angle A and it goes straight down and forms this nice 90-degree angle, well, if that's the case, there's one way to do that. There's one triangle that can be created. Okay. Now, I could find that side length. Okay. Even in this particular triangle right here, if I were to use green, if I were to just draw a couple of dots going straight down. That'd be like, we call it H, okay, as in H, like the height of the triangle. So H goes straight down as perpendicular, so we just made a right triangle with A being the acute angle. So A is opposite side H, and it's over the hypotenuse, right? Well, if I was going to compare these things, you know what, let's just forget about it. We'll just know that that's H, okay? So as I write out this one, A is this side right here. If A is less than H, the height of the triangle, that means we have 0 triangles, right? Now here, let's say A drops straight down, so it is equal to H. Well, if A is equal to H, if A equals the height of the triangle, well, that means we have 1 triangle, right? The other option is, if I were to draw that thing straight down again, here's H, okay? Let's say that, I'll grab my compass here. Let's say that A is longer than H, but not quite as long as B. All right, if that's the case, check this out. Use a different color, it's red. That means my angle could reach, oops, not quite that big. So as we draw this, oh, not big enough. Here we go. As I draw this, you'll notice that it intersects this side in 2 spots. That means potentially I could have a triangle like this, where here's side A, or I could have a triangle like this. Whoops, make it match up. Right there. Well, that's side A. Either way, there's a possibility that I have 2 triangles. So A is less than B, because it didn't quite reach all the way there, but it's greater than H. So if A is somewhere in between H, the height of the triangle, and B, the adjacent side that we know, that means there's 2 triangles that we could make with those measurements. Kind of a weird deal, I know. And the last option is for our side A, the side opposite our given angle. If it happens to be just straight up longer than side B, so I can spin it and measure that okay. Quit jumping. So if it's there, whatever you get the idea. If it's longer than that, that means the only way for it to make a triangle would be right here. Okay, there's no way. It's not going to intersect it any other way with that angle and with that side. So here's side A. So if A is greater than B, that means we have 1 triangle. So lots of different options, okay? First couple, we're comparing it to H, which is the height of the triangle. So in that regard, I want you to think about how I would find H, okay? H being one of the legs of a right triangle. Well, I know angle A, and I know the hypotenuse. Okay, this is a number that's given to me. To find H, I know that the sine of angle A is equal to the opposite side, which is going to be that height, H, over the hypotenuse, which is going to happen to be B in this right triangle. Now, if I multiply both sides by B, H is equal to, and now here's the key as you find this guy, H is equal to B, the adjacent side, times the sine of A, the given angle. Okay, so this relationship is going to help us figure out how many triangles we have as we compare the opposite side to the adjacent side and to the height, determining how many triangles we have for this particular scenario.